Now we are going to weigh out our sodium hydroxide using one of our analytical balances. The analytical balances have are very sensitive and have 4 decimal points after 4 points after the decimal place. An important thing to be cautious of when using sodium hydroxide is that it starts to absorb moisture from the air the longer that you have the bottle open, and then it gets sticky, which causes it to easily be transferred about because it sticks to every surface. These pellets are approximately 1/10 of a gram each, so usually we take about 5 of them. We don't have to be super accurate about this. We don't have to get right at 1/2 gram as the instructions call for, just because this is the catalyst used in our reaction and it's not going to mess it up if we're not spot on. So it looks like we're at around 0.58 grams, and that's going to be just fine for our purposes. The next step will be to transfer it to our mortar and pestle and grind it up. In this step, we're going to measure out our methanol into the 25 milliliter graduated cylinder. We need to measure out 14 milliliters of methanol. When measuring liquids, it's important to measure to the bottom of the meniscus. The meniscus is a concave shape that forms when the liquid sticks to the side of the glass. You can see it with most liquids, and it is dependent on the surface tension the liquid has. So methanol gives you less of a meniscus, although it is visible. Water or something like that gives you quite a large meniscus. As I mentioned before, it's important to deal with volatile liquids under good ventilation, and just out of the shot is our fume snorkel that is taking away any exhaust fumes. After measuring out our methanol, we're going to set it aside for the time being and grind up the sodium hydroxide with the mortar and pestle. So we haven't done this step yet because we need the methanol to help us remove the sodium hydroxide and get it into the Erlenmeyer flask. After grinding the sodium hydroxide, a lot of the powder will be stuck to the mortar and the pestle, so we're going to use a spatula to help us try and scrape out as much as we can. Once we've scraped as much as we can into the Erlenmeyer flask, we're then going to use the methanol that we measured out to help try and rinse off and dissolve some of the residual sodium hydroxide into the flask. This is another reason why it's not such a big deal that we over measured our sodium hydroxide a little, is because we always lose some in this step. The next step is to measure out our chosen cooking oil. We have chosen corn oil for this. We need 60 milliliters. We're measuring it into the 100 milliliter graduated cylinder. Remember to measure to the bottom of the meniscus. After we've measured this out, we're going to add it to our Erlenmeyer flask, which contains the sodium hydroxide, the methanol, and a stir bar. In this setup, we've also attached a temperature probe, which is that kind of white stick coming out of the top that goes to the little brown cord. That enables the hot plate to set the temperature of the liquid for us, and it helps us with accuracy of temperature. So once we've added our liquid, all we need to do is set the temperature probe placement in the liquid to make sure that it's not going to hit the stir bar, and then we can start our heating ramp. We're going to ramp the heat in 2 separate steps because it tends to overshoot a little bit. So we need around 50 degrees C for the best conversion, and so we're going to first set it to around 35, let it hit that, and it's probably going to overshoot, and then we'll set it to 50 and it'll get there more slowly and more accurately. We're also going to stir the solution such that it is not too vigorous, but also we want it to be mixing thoroughly. Once we've reached temperature, we're going to allow it to heat for 20 to 30 minutes. Usually I go on the longer side to get better conversion, and then we will pour it back into our large graduated cylinder, which we will have cleaned for the separation, which happens overnight. Once the reaction has completed, we will just turn off the heating and stirring plate, remove our temperature probe. Now the temperature probe does have the reaction product on it, so we will be sure to clean it appropriately later. And so to prevent the stir bar from ending up in our graduated cylinder that we're going to pour the product into, we're going to use a magnetic stir bar retriever, which is just a larger, strong magnet. And we will hold the stir bar into the Erlenmeyer, and it will stay there as we pour our solution. So this solution is around 50 degrees C, which is not going to burn you, but it is quite hot. So we're very careful in our pouring procedure. After we're done pouring, we are going to put a cover on top of our graduated cylinder and leave it to cool. There will be 2 layers that form, which are the 2 different major reaction products, one being the biodiesel and one being glycerin.